right. Arithmetic, right? Fundamental theorem of arithmetic, right? Let P be a prime number. If this P divides square of any number, for suppose if P divides a square, it is prime number. If this P divides a square, P, we can conclude that P also divides a, right? This is the fundamental theorem of arithmetic. Depending on this theorem, we can prove irrational numbers as irrational number using contradiction method. Okay, now we will discuss of proving root 2 as a irrational number, right? Even though root 2 is irrational, we will assume that root 2 as rational and we will prove that as irrational by using contradiction method. We know that every rational number is in the form of a by b, where a comma b are coprime integers and b should not be equal to 0. It is our definition according to rational numbers, right? And we will take this definition into this question, and look at here, this coprime integers plays major role for this question, for proving this question. Look at here, coprime integers means a comma b has highest common factor HCF as 1. It does not have common factor more than 1. Coprime means, the meaning of that one is, coprime means a comma b has HCF as 1, highest common factor as 1, right? By depending on this condition, I will prove here root 2 as a irrational number, right? Right, now I'm assuming let as, look at here, let us assume root 2 as rational number. Root 2 is not as, root 2 is a rational number, right? Now if it is rational number, it can be in the form of a by b, right? And then a by b, right? A comma b are coprime integers where b not equal to 0. B should not be equal to 0. And then I'm squaring on both sides. That will become 2 equal to a square by b square. Square root gets cancelled. 2 equal to a square by b square. Clear? And then here I can write b square equal to a square by, I will transpose this b square this side, this 2 this side, and here 2 divides 2 divides a square, then 2 also divides a, right? Here 2 divides a square, 2 also divides a, by using fundamental theorem of arithmetic, which we have discussed before. Fundamental theorem. Arithmetic. Right now, and therefore I can, if 2 divides a 2 is the factor of a. Right now, again let a equal to 2c. I will explain why I am assuming a equal to 2c. Right, we know that b square equal to a square by 2, right? B square equal to a square by 2, right? And then I am taking instead of a 2c, b square will be 2c whole square by 2, right? B square can be 4c square by 2, 2 ones and 2 times. I can simplify this as b square equal to c square, then c square equal to b square by 2, right? Transposing this 2 towards this side. And here we can say that here we can say that b square divided by 2, right? Or otherwise 2 divides b square. 2 divides b square. That means 2 also divides b, right? 2 also divides b by using fundamental theorem of arithmetic, which we have discussed in the earlier cases, right? Therefore 2 is the common factor for 2 is the common factor for a comma b, right? 2 is the common factor for a comma b, but we have, look at here, we have assumed a and according to our statement, according to our rational number statement, a and b should have HCF, highest common factor, as 1, but here we got a common factor as 2, but it is contradiction to our fact, right? What is that fact? Rational number, right? It is therefore a comma this, okay, otherwise we will write this as therefore this contradicts the fact that a comma b are coprime, opposite, right? We have assumed as coprime numbers, but we have got those are non-coprime numbers, right? Therefore this contradiction has arisen. Contradiction has arisen due to our assumption. Since we have assumed root 2 as a rational number, this contradiction has, this opposite statement has arisen. That is why this contradiction is due to our assumption. Therefore our assumption is wrong. What is our assumption? Root 2 is rational. Then what is correct? Therefore root 2 is irrational. This is the proof for proving root 2 as